Good morning, everyone. I think my audio and video are clear. Morning. Right. Just I will remind you yesterday's topic. Let them remaining members also join in the class. So yesterday we observed a reaction of acid with metal carbonate and metal hydrogen carbonate. That required materials are on the screen. For that, we are setting the apparatus as followed here, taking the retard stand, fixing the boiling tube to the retard stand, then filling it with a acid, that is here HCl. You may conduct this activity by taking H2SO4 also, it's not a problem. Then arrange your rubber cork delivery tube, thistle funnel, fix it to the boiling tube, then take one another test tube or boiling tube which is filled with lime water, calcium hydroxide solution, then add a metal carbonate into HCl through thistle funnel, then observe what happens, right? Then that reaction takes place, that carbon dioxide will be released. In this case, that will be what confirmed by you by using a lime water turned into milky white, or using the burning matchstick test. Immediately it can be put off. So that can confirm the releasing of carbon dioxide gas. Right? So here in this reaction, we observed especially in two boiling tubes, we observed different changes. Right? In the first one, releasing of gas. In the next one, lime water changed into milky white color. Right? So these are the observations. So for them, you are able to write the equations also, right? So they are here like this: sodium carbonate on reacting with hydrochloric acid, producing the salt, water, and liberating a gas, carbon dioxide. Right? If you conduct this activity by using a metal hydrogen carbonate, that means sodium bicarbonate or metal bicarbonate. Here, sodium carbonate, bicarbonate reacting with HCl and producing a same products. What they are here: salt, water, and carbon dioxide. In another test tube, we observed a few reactions. What they are here: lime water combined with the carbon dioxide and giving you a precipitate, undissolved material, white color precipitate. That is here calcium carbonate and liquid water. Right? Then on passing of excessive amount of carbon dioxide into the lime water, again it reacts with calcium carbonate, water together, then it produces calcium bicarbonate. Right? It produces calcium bicarbonate. So this is the reaction. By observing this sodium carbonate or sodium bicarbonate reaction with the HCl, commonly we are obtaining the three products. They are here: salt, water, and carbon dioxide. I didn't mean always that NaCl forms, right? If you change the carbonate here, suppose instead of taking sodium carbonate, if you take calcium carbonate, CaCO3, what happens? Here you will get a salt, that is here calcium chloride. Instead of NaCl, you will obtain calcium chloride, right? So this is, then is it a balanced equation? What we are written reactions? No, they are not balanced equation. See here, hydrogen count different, sodium count different. Make it balanced. So 2 NaCl, Cl changed to 2, so 2 HCl. Now it is said to be balanced equation. What about the second one? Here Cl not balanced, so here also we can put 2 HCl. So count of hydrogens, okay, say no, count of hydrogen same actually. Here 2 there, 1, 2 there. Then chlorine 1 atom, sodium 1 atom, sodium 1 atom, oxygens 1 plus 2, 3 atoms, carbon 1 atom, carbon 1 atom. Actually, second reaction is balanced equation. Only the first one you need to balance. Already I balanced it. Then check these also. Are they balanced or not? Compulsory. It must be balanced equation to satisfy the law of conservation of mass. Right. Then here we are able to generalize these reactions in the boiling tube one. Right. What they are here? Reaction between metal carbonate and HCl produces salt, water, and liberation of carbon dioxide gas. Right? If metal hydrogen carbonate is reacting with the acid, that can produce also same materials, commonly salt, water, and carbon dioxide. Always that salt is not same. Salt respective to the carbonate or bicarbonate, it changes. Right? So I think it is clear to you everyone, this activity. Any confusion? Shall we go to another activity? It is yesterday's activity actually. Is it clear? Yes. So we will go for next activity. That is here activity number 5. Activity number 5. That is simply here reaction between, sorry, just a second. Just a second, I will be back. Yeah, thank you. Just a small mistake there in the slide. So that's it. I corrected that. Okay, here now we are going for another activity, that is activity number 5 here. That is the reaction of acid with the base. What happens if a base or an acid react with a substance with opposite nature? Acid with the base or base with the acid. On reaction of these combination, what happens? That we need to observe here. So for this, I required a few materials. So what is my aim? Can anybody write the aim of this activity? Anyone? What is the aim of this activity? For what purpose we are conducting the activity? Here to observe the reaction between acid and the base. So to observe the reaction of acid with the base or base with acid, whatever it may be, you can write. Then what are the materials required here? You are required few materials. They are here NaOH solution, NaOH solution, HCl solution, hydrochloric acid. Next, phenolphthalein indicator. Why? To observe the product nature. By the combination of acid and base, you will produce a product. By that, you are observing the product behavior, either acidic or basic or neutral, right? So that's why I need indicator. Along with this, I need a boiling tube, right, to take that HCl and NaOH into the container. That is boiling tube here I am using. Then dropper to transfer the acid and base. Don't handle them directly with the bottle or something else. Just use the dropper, right? Don't smell it. Handle with care. Then next here I need test tube holder. So to hold the boiling tube. So these are the required materials. Sodium hydroxide, hydrochloric acid, phenolphthalein indicator, boiling tube, dropper, and test tube holder. So these are the required materials. Now, how to conduct this activity? So let us go for procedure here. So first of all, you need to take a boiling tube. So boiling tube is taken. Hold it with the test tube holder in your hand. Then use the dropper to add any liquid. So first of all, I am adding NaOH, right? I am filling with NaOH into the boiling tube using dropper. So NaOH is added. So what we filled actually first I filled NaOH solution in boiling tube, right? NaOH added. Then here, what is the nature of NaOH? Can anybody? What is the nature of NaOH?
Sir, basic.
Basic in nature. What happens if I add phenolphthalein indicator? Now I will add phenolphthalein indicator in this. Phenolphthalein indicator I am adding. What happens on adding phenolphthalein indicator into the NaOH solution? Answer me.
It turns pink color.
Very good. It turns into pink color. So I am adding now phenolphthalein indicator into the NaOH solution. Add 2-3 drops of phenolphthalein, then wait. What happens? So on adding phenolphthalein indicator into the NaOH, it changed into pink color, right? So here simply I confirmed the behavior of NaOH in the presence of phenolphthalein. What it is? Basic in nature, right? Phenolphthalein basic in nature. Sorry, NaOH basic in nature, right? NaOH basic in nature. So that is confirmed by the phenolphthalein changed into pink color. Phenolphthalein turns into pink color. So that is confirmed the basic nature solution is NaOH, right? Then what to do here? I have one more liquid, that is what? HCl. So now I can add HCl solution into the NaOH solution, which is in pink color. Same solution, which turned into pink color. That solution added by HCl now. So in the third step, what I am doing here? I am adding HCl dropwise, slowly, dropwise. I am adding HCl. That which is in pink color, right? So now start adding of HCl into pink color solution. So now slowly dropwise add and wait, right? Add up to turn the pink color into colorless or vanishes of pink color in the, yes, it is vanished. Now stop adding. Did you see that change? On adding of HCl into the pink color solution, what happened? What do you observe? That adding continuing up to what time? Adding that HCl into pink color NaOH solution. Up to what time I added? Anybody? What do you observe? Right? So here up to vanish of color, right? You can add dropwise, slowly HCl into NaOH. So now the pink color vanished. Don't add any drop of HCl into the NaOH solution when it started to change its color, vanishing of pink color, right? Now here you can test the nature. You can check the nature. No need to check actually. When phenolphthalein changes into colorless, what the solution nature is? What the solution nature is? Phenolphthalein remains colorless. Phenolphthalein remains colorless, indicating the nature. Respond.
Sir, acidic.
Confirm?
Yes, sir.
No. We have two options actually. It is maybe acidic or neutral. Yes or no?
Yes, sir.
Yes. But I am saying here that is with acidic or neutral. Here it is not acidic. I am saying it is neutral. How can I? How can I? I am saying it is neutral. How can I? What is the reason? What is the reason? No one? No idea about it? See here, base, right? What is in the boiling tube actually? First, we have base. First, we have base, right? Then, slowly HCl added, right? HCl added, completely opposite nature. Base plus acid is taken. So here that vanish of pink color, giving you a new substance, colorless. We are added slowly, drop by drop, right? Just we are giving gap between drop to drop, adding next drop by giving small gap. So here, when it remains as colorless in the beaker, immediately stop adding of HCl. So that colorless solution is neutral in nature. Then here I will change the concept here. Up to now I added HCl into the NaOH solution, right? Up to what time? To vanish the pink color in the liquid solution. So I decided that nature is neutral. You can confirm by using another indicator, maybe litmus paper. You can use it, red litmus and blue litmus, probe them. Then you will finally confirm that colorless solution obtained by the NaOH and HCl is neutral. Then here I am changing the concept. Here I can add 1 or 2 drops of NaOH solution into this colorless solution. Same boiling tube, right? Colorless solution I am using. I am adding here 1 or 2 drops of NaOH solution into this. Then wait, what happens? Observe. See here, it is again changed into pink color, reappeared in pink color, right? On adding of what I added, that colorless solution now added by NaOH by 2 drops. So it reappeared. What I observed, reappeared in a pink color, right? Reappeared in pink color. What pink color indicating us? Answer me. What the pink color giving identification result? What do you notice here? Here finally we can confirm again it is changed into basic nature by adding. So here the colorless solution what you obtained, it is what? Neutral solution. So by the reaction of acid and base, you are able to produce a neutral substance. So this reaction between acid and base named as neutralization reaction, right? This reaction was named as neutralization reaction. Are you clear? Any confusion? Any confusion? Everyone, if there is any confusion, just immediately respond to me. No confusion. So here I am generalizing this reaction as neutralization reaction, right? Why? By the base, I changed that basic nature into neutral on adding of acid, right? So I realized that changed into neutral because of phenolphthalein solution already present in the NaOH. Look at that stepwise. First, second, third, right? Next, fourth step is adding up 2 drops of NaOH. So here reappeared in pink color. Again, it is adopted by the basic nature that I confirmed. So here, simply I am able to write a generalized equation here. What is NaOH aqueous solution is taken in the boiling tube, and I added HCl to that solution. By the reaction of NaOH and HCl, I obtained a colorless solution. That colorless solution is NaCl aqueous solution that which dissolved in the water. So I have 2 products here. That is NaOH HCl reaction, that is acid base or base acid reaction, given me salt and water. Both are in liquid form. So here, if you conduct this activity using any other, you will get the same, right? So finally, you can generalize this equation or reaction as acid plus base or base plus acid, any combination, right? That both are commonly producing salt and water. So this reaction is named as neutralization reaction because the salt is produced with a nature called neutral, right? So this reaction is called neutralization reaction. Everyone understood this concept? Is it clear? Yes, right? So confirm. Now we'll go for another examples also for them, right? So you are able to carry out this neutralization reaction by using different compounds. If you want, I will give you many examples we have, right? So what they are here, simply that generalized equation we are written already again. So I'll give you few more examples for this neutralization reaction. I'll write on the screen, just note down them. That is the reaction carried out by the magnesium hydroxide with HCl. The reaction carried out by the hydrogen bromide HBr between potassium hydroxide. Here hydrogen bromide is acidic nature. NaOH with sulfuric acid, right? Sulfuric acid with potassium hydroxide. These are examples for the neutralization reaction. Only one example given in your textbook. In the activity number 5, you can add these examples also as neutralization reaction. If the question come in your exam, write example for the neutralization reaction. You can use these examples. Later on, you will get one more example, that is in your digestive system, right? That we can discuss later. So you can add many examples in your list. Okay, so this is about neutralization reaction. Then later on we have activity number 6, that is reaction of acids with metal oxides, or one more combination also there in this, the reaction between the base and a non-metal oxide. So 2 types of reactions we are observing in the activity 6. What is activity 6? Reaction of acid with the metal oxide and reaction of base with a non-metal oxide, right? So what is the nature of metal oxide? Can anybody give me example? Metal oxide and nature. I need one example for metal oxide and give me the nature of the metal oxide. Already we discussed that in activity 1. In activity 1. Also we discussed in lesson number 2, activity 1. No example with you? No example with you?
Magnesium oxide.
Very good. So one of the example given here, magnesium oxide. What is its nature? Its nature? Acidic, basic, or neutral? Acidic, basic, or neutral substance? It is basic in nature. It is basic in nature. In lesson number 2, calcium oxide, quicklime, added to the distilled water, and finally you produced calcium hydroxide, right? So here already we used indicator to check the nature of calcium hydroxide. We decided its nature is basic. Its nature is basic. So here that distilled water actually has no nature, but it is turned into basic due to what? Calcium oxide only. So metal, calcium is a metal. It is a compound metal oxide. So that metal oxide nature is what? Basic. So that's why magnesium oxide also basic in nature. It is given in your 7th class and also in 8th class, metals and non-metals lesson. Magnesium burned in the presence of oxygen, that giving you magnesium oxide. And that white color powder you are taking into a watch glass, then adding few drops of distilled water and finding the nature. With litmus paper, you will decide that nature of magnesium oxide is basic, right? Because here addition of water to the magnesium oxide produces another substance called magnesium hydroxide. It is due to the distilled water, we will decide. Because distilled water has no nature, it is adopted by the magnesium oxide only. So this is the reason to say metal oxides are in basic nature. Have you got clear information how we are deciding the metal oxides nature? Yes. So very clear, right? So now we are using that metal oxides to test the reaction with acid, metal oxide and acid. Next, base with non-metal oxide. Metal oxides, non-metal oxides, both are opposite, right? So metal oxides nature is what? Basic. Non-metal oxides nature, can anybody guess? Metal oxides are basic. What about non-metal oxides?
Sir, acidic.
Very good. They are acidic. So here, what the reaction you are carrying out between acid and the metal oxide? Look at here. Already you decided metal oxide's nature. This is what? Base. So what the reaction you are carrying out? Acid and a base reaction. What the acid and base will produce as per activity?
Salt and water.
Very good. It is salt and water. So nothing but it is also a neutralization reaction. I think you may got doubt here. Anybody can ask me a doubt here? Anybody ask me a doubt here? No doubts? No one getting doubt here? If acid and base reaction producing the salt with neutral nature, how do you get salts with acidic or basic nature? Did you realize in your doubt? Is it correct to ask here? I may ask you the correct question. Can anybody answer my question? Always the acid and base reaction giving you neutral salts. If it is possible, how do you get the salts with acidic or basic nature? Is it possible to get it? No one answering me. Don't know? Don't know? Use quick reaction. Do you know or not? If you don't know, I will reveal that answer. Okay, I'll give you simple. What you are doing actually in a container, you are taking acid or the base and slowly dropwise you are adding another substance, right? What is here? Base. So it depends on you how much amount you are adding. Are you trying to produce a neutral salt, or are you trying to produce acidic salt or basic salt? That will be decided by you only. It is by you only, right? To produce the salt with suppose basic in nature, I will add more amount of base into the acid. If I want acidic salt, I will add a less amount of base, right? If I add, right, to vanish the color, then what I will get? Neutral. So it depends on me only what I want exactly, the nature of the salt. Did you got answer for that question? Answer vachinda leda? How you are able to produce acidic salts, how you are able to produce basic salts. So always it is not compulsory to produce the salt with neutral nature. Always they are not neutralization reactions, but what we can call acid base reaction is neutralization reaction. Here you are adding the opposite nature substance into a particular nature substance, right, to neutralize it. That reaction we can call it as neutralization. If you decrease the quantity of any substance, increase opposite, then automatically the salt will adopt the same nature, which is large in quantity, right? So this is what I want to say. So we'll continue this activity in the next meeting. This time only 3 minutes left. So join immediately.